So as I said, I'm going to go through a video that I believe the FIA posted to YouTube, and in this video they're going through the regulation changes that are about to happen for the new season with the LM hypercars instead of the LMP1 prototype cars that they were using before. And the reason for switching is because a lot of manufacturers were complaining that there was a lot of cost to develop a car at that rate for a race like that and to remain competitive and everything. And also it was getting a little stagnant from a viewer's point of view because the racing, all the cars kind of look the same and everything, and that is kind of the same thing that's going on in F1 and all of it. But that is just the way science has proven cars should look in order to behave the way they want to. So they're now stepping back, and now they have launched a video to kind of declare the regulation changes and all of that. So I wanted to go through the video to kind of see what narrative or what thought process will be behind and what kind of the storyline for the car will be. And afterwards I hold it real quick.
LeMans Endurance Hypercars, a new name and a new concept for the top class in world endurance racing. Debuting in 2020, the category offers manufacturers and privateer teams the chance to compete head-to-head for outright victory. Several key factors will govern performance.
Here we go.
The minimum weight will be 1,100 kilos, with a powertrain average of 550
So I'm going to put that on pause. So here are a little bit more of this actual facts of how the car is actually about to operate. So the weight will be 1,100 kilos. So with a powertrain average total output of 750 horsepower, 550 kilowatt hours of juice. So that would be kind of the window for operation. So you can kind of know that your engine needs to be at that performance, and also what type of materials you would use to be able to achieve a minimum weight that is as close to that 1,100 kilos as you can get for a car of that type. So performance level through 3 minutes and 30 seconds. So we can actually go to the PlayStation in a couple of seconds and go to project cars and then see what type of car is actually capable of doing that, and then we can also kind of see what the optimum performance would be of that car, so we could kind of use that as a benchmark, or as a benchmark. That's a proper word for it. But and then with that we can kind of see what suspension setup it is. Is this car also actually at the 1,100 kilos, or is it maybe a little bit below or above? And can we maybe just, gradually just find things to narrow the window down to get as close to the performance level we are aiming for. So with that being said, I now know that I have to produce or have to design an engine that is probably capable of 750 brake horsepower. So the way that I look at it is pretty simple actually. If you have a motor that is producing like 100 horsepower for every liter, that is basically the standard today for a motor that has like double overhead cams and everything. And if you don't know what these things mean, I will go to it more while I'm in the process of actually developing the car, because that is what I'm going to do right now. So basically every car today, modern engines in Europe at least, have a double overhead cam setup. So this means that for these engines, basically for every liter of engine capacity it has, it will probably be capable of producing about 100 horsepower. And that is if you have a border stroke ratio. I'm getting pretty technical, but stay with me. That is if you have a border stroke ratio that is about at 1:1. So that means that the bore, so the actual width of the piston is the same distance as the piston is traveling up and down. So that is the crank stroke. So that is the size of the crankshaft itself. And that will kind of regulate, and there's a very close relationship between the length of the crank stroke and the width of the bore. So if you have a 1:1 ratio, that means that those two distances are equal. And if this is the case, you have an engine that is producing about an equal amount of torque to horsepower, and also revs to maybe a maximum about 8,000 RPM for road cars. So yeah, that is in those cases. If you start to have an engine that is producing, not producing, but it has a border stroke ratio that is closer to 0 than 1, or below 1 I should say, then you will start to have a motor that will decrease its RPM, and it will start to increase its torque output lower in the RPM, because now there is a smaller piston with a bigger stroke. So it will take, that piston has a long time to travel. There's a long time to really get all of the forces of this gas explosion, and that's a long time to expand. And it will come up as well with this, this about the same speed. And this now means that it doesn't really want to go very fast because this piston has to travel a very long range, but at the same time it will have a lot of power. So that is why at low RPM these motors produce more torque and will be better to accelerate off the line, but at higher RPM the top speed will kind of lag out. And this is what more the British cars and especially American cars have. These are bigger stroke motors instead of being very revvy motors. In Italy and the smaller countries in Europe, these there used to be like laws on how big the engine could be. So what they did is they got a very small capacity. So the bigger motors back in the day from Italy were like 3-liter V12s, especially from Ferrari. But so they were small capacity, but they had a lot of cylinders, so there was a lot of volume, and also the pistons would be bigger than the actual rotation, than the actual stroke, I should say. So what you would have now were these motors that were producing a lot of gas power, a lot of gas pressure, I should say, because of the amount of cylinders that there is, and also at a very high RPM. So they would get maybe like close to 350 horsepower out of a 3-liter motor. So that would be pretty powerful for cars back in those days. So that is with a bore stroke ratio that is higher than 1. So then you start to produce engines that will rev higher and also have their peak power at the higher RPM. So that is a very long explanation. I'm sorry if it got a little bit too technical, but I'm saying all of that to say that if we now know that we have a 750 horsepower capacity, then we can kind of judge if we want a car that has like more than 7 liters. So if you want like a bigger motor, that if we're talking about natural aspiration, and I don't think that we will do that, but let's just keep it at that for right now. Or if you want a car that is going to produce more horsepower at high RPM. So that means that we could keep the capacity low, keep the engine block itself small to, maybe do for packaging purposes and all of that. So that is kind of a question you have to ask yourself, if what type of characteristics you want from your engine, and then according to that you can then decide on how to build it and everything with the rest of the car, and that will also determine how the rest of the car will look, because you need to really get all of the, for aerodynamic purposes, you need to shrink wrap the car. So if you have a big engine, then you will see that, and the rest of the car will also become bigger for the rest of the aerodynamic package, and also to increase and to deal with the high weight of the car. So I'm talking way too much, my bad, sorry. Then we have a performance level F330, I explained that, and a single tire supplier. So that means that also all of the rims will be standardized, probably. Maybe there will be their own team's design, but they have to fit within the sizes and the dimensions of the tire. And that is also something that is very important in your design process. So I don't know how quickly you can actually start with the design if you don't know how big the wheels will be, because that is very important also from an aerodynamic standpoint, because wheels generate a lot of turbulent air that you don't want. So yeah, you have to figure that out. But for now, let's continue with the video.
Watts or 750 horsepower.
Another thing I wanted to mention, that if you are designing a car, designing a front axle that also drives the car is very important in the way you develop the rest of everything aerodynamically, because if you don't have a system in the front of the car that is taking up a lot of space in that area, then you might be able to be more aerodynamically efficient, because you don't have to have like a wall or bodywork to protect it. So then the car can kind of look more like the Aston Martin Valkyrie does, with its very narrow nose, and it doesn't really have a lot of vertically standing surfaces on that car. So the air that is really hitting it and that has to go around it, that's not happening like in that aerodynamic design of the vehicle. So that is also a major advantage to have at LeMans with the long Mulsanne straights and all of that. So that's also something to look at the competition, but that is for a different video. So yeah, so that is another point of design importance, that if you want something to power the front axle, and if you're going with that hybrid system that is also going to add a lot of weight, then that is something to take into consideration with the aerodynamics of the car. and complete total packaging, and also the heat management of the battery systems and all of that. It takes some thought. What do I have to say about what I will do to the car? So it has to be like a cool looking hypercar, because as a designer I'm always try to make a good looking design, but I also want like a whole bunch of performance targets to be achieved. So um you also need to look at the competition, because if Aston Martin Valkyrie is coming along and doing this race, what they announced to do, and also companies like Koenigsegg and maybe even I believe Toyota is also competing, but these cars that are trying to compete, they have some real downforce numbers as well. So um, you need to achieve, I think a goal I will set for myself to design this car is to produce the car's body weight with another 30% of that of downforce. So if the car is weighing 1100, then it should produce like 1330. So something in the 1300 kilograms, something in the neighborhood of downforce. So I think that is also kind of what Aston Martin is doing. That is something, a target that I would set for myself. So that is one. To achieve the level of downforce, you need a whole bunch of probably underflow of the car as well to be good. And to achieve this, you would kind of need to go for a setup or an aerodynamic strategy, as Aston Martin did with the Valkyrie. If you try to go for that, then it will probably become impossible to go with the actual front axle driven electric power. But I kind of do want that, because it kind of makes it more of a design challenge for me to kind of see if I can come up with a way to incorporate to incorporate all of these systems together with heat management and all of that. And also, so I like the design challenge of it, and to then also go along and still produce all of the downforce that you need. That kind of seems very interesting to me. But still, I have to tell you that all I'm doing is theoretical, and it's not really. I don't think I have the possibility to prove that it will work, because I don't really know a lot about software simulations to actually check what the temperatures in these cases will be. So I might get somebody that's interested to maybe look at some of the numbers and everything, an engineer that is willing to help out with a project like this. I'm open to all of that, and if it generates enough interest that people try to want to see the car, then maybe we can actually build it. So we'll see what happens, but that is what I'm aiming for eventually. But for now, it's just a fun design project, and I'll just see where it ends up. But what I do want to say, so I am going for the front axle with the aerodynamics and everything to incorporate all of these systems, because that design challenge is just fun. So I am going for that. And what type of powertrain would it have when it comes to just the motor itself? I think I want to go for a V8, because if this is based on like actual hypercar, then I also need something that kind of sounds nice. And I like these high revving, like naturally aspirated flat plane crank V8 sounds and everything from like the Ferraris and everything. I actually do want to go turbocharged as well, because with the hybrid system incorporated in it, it's hot as hell in here right now. With all of these hybrid systems incorporated, you kind of get a motor that is maybe if you go with a motor that's turbocharged, then you can make it smaller, but you can produce a motor that is now maybe producing more of its peak power at more of a RPM, because you need all of the gas power to go through these turbines to actually put more air in there. So and then the electrical systems could kick in and help with that process as well, to kind of put the power down when the motor is not performing at its optimal rate at lower RPM, kind of how the McLaren P1 is structured. So that is also very interesting to me. Or I could maybe do even like a hypercar system with turbochargers that are mounted to electrical motors to kind of add revolutions to the turbine when the gas power of the exhaust is not enough to rotate it. Yeah, so that is kind of the direction that I want to go for. So a high revving V8 that is still turbocharged, and I know that high revving and turbocharging is kind of going against each other, but I do want to produce something like that though. Maybe you'll end up with something that is a little bit Mercedes like, but as when it comes to the motor. But I think I'm going for like maybe 2.5 liters, and then with about 2 bar of turbo pressure on it. So what you can do then is have a 2-liter motor that of a 2.4-liter motor. So in a natural aspiration situation, it would produce 240 horsepower, but then it would kind of go a little bit more towards 300 because I'm now making it a high revving motor, and maybe even more towards like 310 because I also have for a low capacity, I have a lot of cylinders. I have 8 cylinders. So usually for like a 2.4-liter motor, you would have like a 4-cylinder or a 6-cylinder. Now you put it on 8 cylinders, so you have more gas pressure, more explosions per revolution. So that also bumps the power up a little bit. So with already at 300, let's say 310 horsepower for this motor, if it would be naturally aspirated, and now you can almost double that to maybe like even 600 something. Because you're now putting double the air in there with the turbocharging system and everything. So yeah, that would pretty, but then you kind of need a little bit more. So maybe a 3-liter V8 would be where it's at. A 3-liter twin turbocharged V8. That would be dope. That would be very dope. And the last thing that I am going to mention before I kind of give myself like the parameters and the guidelines of what the car will be, I think I want to make a reverse flow engine, meaning that the hot exhaust gases are actually coming out the top, and that the lower temperature air intake is actually coming from below instead of the other way around. And what this allows you to do is make for a smaller packaging, because now the exhaust is now in the middle. So what you can do with all of that heat that is produced at the top is also ejected out immediately from the airflow that's coming over the car, so you can release it immediately in that airstream. And what this does is keep all of the it keeps all of the heat at the top, where it can go immediately down in the atmosphere, and it keeps all of the cooled air, trying to keep the car cool and keep the car also keep the engine air intake, air temperature as low as possible. You can now separate those two sections off from each other very well, and also have like very good heat management in the rest of the car. So that is something that I am thinking about. So twin turbocharged hot inside feed, that is what you call when the turbochargers are actually in the block, with a hypercar system and a front axle that is also electrically driven, and it needs to be a hypercar. So probably the monocoque needs to be able to fit 2 full-size human beings. So you would also need to be going to kind of a monocoque that looks a little bit Aston Martin Valkyrie, maybe even Rimac Concept C2, Rimac C2. Check out the video from their factory tour if you haven't. Very amazing. It's dope. So that is also something that I'm gonna do. Yeah, I got it down. That is the plan. I'm gonna start drawing some shit up, and I'm gonna start working on that motor. 3-liter V8, maybe even a wider V that is at like maybe beyond a 90-degree angle. Maybe I should do a boxer motor. Ooh, I'm gonna think about that one. This is getting fun. I'm getting back in my zone. 8-liter boxer. Okay.